Alright, this is going to be a video on graphing trig functions, and I want to just throw up this page real quick. It looks like a big mess, and it's because it is. Uh, what I'm going to do is I'm going to be working with pi over 2, 3 pi over 2, pi, and 2 pi. But we're going to be doing some shifts, and so it's important to understand some of the other things as well, and so, some of the other values as well. So I did all the way from pi over 12 to 24 pi over 12, which is 2 pi. And so 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12. These all end up in the first quadrant, and then 6 pi over 12 is pi over 2. And that's, if you look at our unit circle, it goes 0, pi over 2, pi, 3 pi over 2, and then 0 and 2 pi kind of share, if you will. Anyway, so 6 pi over 12 is really on the cusp. Quadrant 2 is 7 pi over 12 to 11 pi over 12. 12 pi over 12 is pi. Quadrant 3 is here. Quadrant 4 is here. And then I like to make what I call the dragon. I start at 0, and it goes pi over 3, pi over 4, pi over 6, pi over 2, and then up. And the reason why I do this is because these are all the reference angles. 2 pi over 3 is the same as pi over 3 is a reference angle for 2 pi over 3, 4 pi over 3, and 5 pi over 3. Easy way to remember this is 1 pi over 3, 2 pi over 3, 4 pi over 3, and the reason why it's 4 and not 3 pi over 3 is because they have no common factors, and then 5 pi over 3 has no common factors. Same with pi over 4. 2 pi over 4 doesn't work because it has a common factor of 2. 3 and 4 don't, 5 and 4 don't, 6 does, so 6 doesn't work, and then 7 pi over 4 works. Pi over 6, it goes 2 does, 3 does, 4 does, but 5 does not have a common factor. 6 does, 7 does not have a common factor of 6. 8 does, 9 does, 10 does, but 11 does not have a common factor of 6. And you can see 5, 7, and 11 right here in quadrant 4. 3, 5, and 7. 3, 5. Oh. 3. Oh, goodness me. 5 and 7. Oh, yes. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Goodness me. These are my reference triangles, my special 45, pi over 6, pi over 3, and pi over 4 triangles. Anyway, let's get into the good stuff. The actual trig graphs. Trig graphs are continuous functions, and their domain is from negative infinity to infinity for the y equals sine of x. And if you go back to the unit circle, you'll remember it has a radius of 1. So what happens is, if we look at one full oscillation for y equals sine of x, it starts at 0, it goes up to 1, down to 0, down to negative 1, and ends at 2 pi. And that's one full oscillation. We say that's the period, and it's one full period. Same with y equals cosine of x. The maximum value is 1, the minimum value is negative 1, and the one full period starts at 0, ends at 2 pi. And the reason why I use pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi is because those are really the most important points in graphing this. It has our maximum value, our x-intercept, our minimum value, another x-intercept, and back to the maximum value. All right, now the tangent function, this is y equals tangent of x. It's a little bit different. And here's why. Although we normally would start at 0 and go to 2 pi, if we did, you're going to have to imagine this part here doesn't exist, all right? Imagine that doesn't exist. And we'd go to here, and you can see it kind of ends, but really 2 pi will go up. And what happens is there's asymptotes, and that's because, remember, tangent is really the sine of x over the cosine of x. And so when cosine equals 0, you end up with an asymptote because it becomes undefined. And because this goes on forever, the domain is negative infinity to infinity unless x equals pi over 2 plus k pi, and k has to be an integer. The range, however, is negative infinity to infinity because these values here are approaching negative infinity and positive infinity. All right, I'm actually going to get rid of y equals the cosine of x real quick. Or, I'm sorry, y equals the tangent of x. I'm going to do hopefully a couple of quick examples which will help out. All right, the first is y equals, let's say, 2 sine of x. I'm sorry, 2 sine of 3. No, I'm sorry, I'm going to erase this whole thing. Let's do y equals 3 sine 2x minus 1. All right, so here's what I want you to realize. The amplitude, which is really the height, is the absolute value of the coefficient of x. So it's the absolute value of 3. It's going to be 3. The frequency is the coefficient of your x, which is, in this case, 2. And what that means is we're going to have 2 full oscillations by the time it reaches 2 pi. The period is really easy to find. It's 2 pi over, we call it b, and the reason why is, I should have written this before, this is really y equals a sine bx plus c. So b, a is our amplitude, b is our frequency, and c is going to be our vertical shift. But here we have 2 pi over 2, which means pi, which means this graph, y equals 3 sine 2x minus 1, is going to have 1 full oscillation by the time it reaches pi, and 2 full oscillations by the time it reaches 2 pi. And the vertical shift, and I hope you remember from transformations, it's going to be a -1. It means it's going to be down 1. Now, if you want to graph this, you might run into some problems. And as always, I'm not working with a program that's terribly kind to people without a steady hand. So please bear with me. And I'm going to have to do this as well. So the very first thing I'm going to do is I'm going to say, all right, what's my amplitude is 3. So I'm going to say 1, 2, 3, -1, -2, -3. And I'm actually going to go down to -4, and you'll see why in a moment. But the problem is, normally I would use pi over 2, pi, 3 pi over 2, and 2 pi. But because my frequency is 2, and my period is pi, this is the key here. This is the key here. So what I do is, to find out, I'm going to start at 0. I need to have 3 other values, and I'm going to call this one pi. So what I do is, I divide pi by 4, and I get pi over 4. And I'm going to do 2 pi over 4. So I have pi over 4. 2 pi over 4 is really pi over 2. And I'm going to do 3 pi over 4. And that's my and then I get pi. And that's going to be my first period. So pi over 4, pi over 2, 3 pi over 4. And obviously, you all know to be doing this with a straight edge and using even intervals. Gosh, it pains me to even do this. After that, I'm just increasing by 1, so I'm going to get 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4. But what is 8 pi over 4? It's really 2 pi. So now take a look. The nice thing about that is, I know that I'm going to be reaching my max and min values and my intercept values, but I went down 1. So really, it's a sine. It's y equals 3 sine 2x minus 1. So because it's sine, it's going to start. It should have started at 0, but I had to go down 1. So I'm going to start at -1, and then it's going to hit my max value at the very first one. But my amplitude was 3, so I had to go up 3. 1, 2, 3. So at 2, I hit my maximum value. Pi over 2, I'm going to be on par with where I started. I'm going to have to go down 3. So I'm going to be all the way down at -4. And then back up to where I started. And this is, albeit very ugly, it's what it actually technically kind of looks like. And then I repeat. I go up to 2. and then it's goodness me, there, there, and then back to there. Goes up, whoa, down, and then there. And that's y equals 3 sine 2x minus 1. It does actually go on forever. This is 2 full oscillations by the time it gets to 2 pi. So let's just check the time real quick. Oh my goodness, this is a long video. I'm going to try one more. Nope, you know what? I think I'm going to stop it here. All right. If you'd like to see a phase shift where we're shifting it left and right, tune into the next video.